Okay, so yeah, these three fundamentals will be our main focus. So at least we know the functions at least. But let me just show you some example on some trivial problem. So if we have this, or let me just start with the function first, okay? And then some example. So function. So what is function? So functions, usually you see in any, I think in any subject, if you have set of variables, right? Like for example, you write like f of x like that, and equal blah blah blah, right? So that means a function is set of rules, okay? Set of rules. That assigns x in a set of D exactly one element. Okay. This is a domain. Okay. Okay. So I'll start with the definition of function. So the important thing of a function is that every x will have one fx, okay? Or every x will have one y. So that should be the default statement of functions, okay? So assign x in a set of domain exactly one element. So domain is basically the home or the beginning, the place where you have the x. So you can, for example, a domain from sets of numbers. For example, the numbers is real numbers. It can be also an integers. Okay, I hope that is you still familiar with that. So in calculus, mostly we are using real numbers. That's most cases. Okay. So if we have this, if this is x, this is y, and we are saying that this part here is our function of x, which means that every x here will have their y or their f of x. Okay. All the x at this line here, we say that this is the domain, okay? And all the results that is exactly here, also we have a line here that is setting up the x and f of x. This is we call range, okay? So range is set up of possibilities of f of x. Okay. And this is one way to represent a function using a graph. Okay. You can use also words, notations, like in mathematical notations. Usually start with x, f of x, where x is element of its domain. So functions can be represented verbal or words, table, graph, and algebra. Algebra means the equations, directly the equations. For example, if you have f of x cubed plus 2x, this is algebra. Okay. Now, what is the problem with this definitions? Okay. Not the problem. I mean, what will cause the functions not to be a function? Okay. So, if we clearly see here, it's exactly one element. Exactly one element, right? And exactly one element. So, let's maybe giving you with a real function here. Let me just make a quick simple graph of maybe just x squared like this. Let's say this is x squared. Or let me just write f of x to get the same similar concept. Well, let's say we have this x squared. If we set up the definition as one element, then this is one element. It's also one element. It's also one element. But sometimes it has different x, but it has same value. That's possible. For a function, that's possible. Okay. But the problem will be arise if we have, for example, is this function of x? Is this function of x? Okay, like it. Interesting one.
Or does it in that point have two values? Like
right. Good point. So one way to tell with whether it's function or not function, you can just draw a line. You can draw a line, vertical line. Okay? You draw a vertical line. Like that. Anywhere. You can draw anywhere here, but you will see this is practically has 2 points. Then this is not a function. Not a function of x, but probably function of y. Okay, still a function, but maybe not a function of x. Okay. But let's just focus on function of x first. Okay. So this has 2 points here, which means it's called the vertical line. Vertical line test. To check whether it is a function or not. So it's better to streak the graph, to streak the graph. We can say maybe the graph is only just one side here. Okay. So if this only just this side, then it's fine. Then it's fine. But if you try to the whole graph here, it's not fine. Okay. And maybe this is the square root of x, maybe. Okay. Oh, I forgot to write the domain here. Domain is set of possible inputs. Okay. The more official way to say the domain. Okay. This way, the speed is okay. Okay, not too fast, not too slow, right? Okay, domain range function. Okay, maybe I will go more details on domain. Okay. So the first thing is how to tell what is domain of some particular problems. Okay. Let me start with I'm just writing the function first. Okay. The questions is domain determine domain of functions. Okay, so about this problem, okay, the domain. Usually, you have a fraction like this, and also it has roots. In this case, cube root. Sometimes it's square root, and you have the denominator here. That will be the particular things that you need to take care of. Okay? For example, the first one, you have the denominator that is a quadrant. Okay? That is quadrant. So perhaps you can check if it is factorized, can be factorized or not. Okay? So that's the first thing. So let's check the factorizations. I think this, right? 2x, yeah. Okay, so when we have this, it's clearly that there is certain x that can make this whole denominator 0, right? It can make it 0. If this is 0, then some number defined by 0 is undefined, right? In terms of just a function like this, that value is undefined, right? If the value is undefined and we are talking about real numbers, then that numbers will be exceptions. We're not using that number, right? We are just not using that number. So we say that this x should not be -2 and x should not be equal 1. But let's check whether there are other numbers that can be put in. I think all the numbers is okay, right? All the numbers is okay. You check 3, 4, you can check other numbers as well. And maybe you can write the line numbers to make all things written down easily, okay? So you can write the exceptions here. Maybe we start with the -2. Okay. So we have this and this, okay? Remember, if you write a circle without any full point like this, we call this open circle. Okay? This is a closed circle. It means that open circle, this number is not included. If you write at this like this, it's the full. It means that it should be included the number. Okay? But since we are excluding the number -2 and 1, we write with open circle. And then I think every number is in the line numbers. So we can just draw like that. Which concludes that the domain, we can write the domain like this. Let's start from -∞, -2. Or you want to write x is element of real numbers, and x is not equal -2, x not equal 1. This is also fine. Or you want to write the words like x all real numbers, except at x except at -2 and 1. This is also okay. Okay, the key to understand the domain and writing the domain clearly is to check. Okay, so every time you see maybe the answer is this, just checking the line number, checking whether any possibility that maybe it can have more than these two, the exceptions, or maybe there is something that you need to be more aware. Always checking back, looking back at the fraction here, the functions, and looking at the line numbers. So I would like to maybe suggest you to taking the line numbers whenever you thinking about domain, okay, or any inequality. Okay. Using the line numbers will be helpful. I think we can take break if you want to have some break. Okay. Just 5 minutes break. Okay, let's continue. Okay, so this is the first example on how to look into the domain of our functions. Okay, the second one. Okay, second one you have the cubic root. Okay, cubic root of x, and then divide by x squared plus 1. So what do you think the domain will be? So we have a cubic x and x squared plus 1.
Bigger than
it be minus?
Can be minus in them.
Can be minus, right? Can be minus. Remember, it's cubic, not the square root. Okay? If it's square root, maybe it will be different problem. But it's cubic root. Okay? So remember, cubic, you can have, for example, if you have a function of a cube, then if you see this, it can be a negative, right? So if you have a negative, then it should be okay, right? So let me just erase this. So if we check all the possibility, like this bottom here, x squared plus 1 is always positive, right? It's always positive because of the square. And you will notice this in probably chapter 3 when you learn about the sketching the curve. So whenever you find this, it's always positive. The one you need to think is the top one. The top one, I think it can be all numbers, right? Negative is also can be because of the cube, right? So the answer is just all real numbers. Okay? So that's how you see the domain. Okay. So domain will be all real numbers. Or you can write all real numbers like that. The question will be, however, a little bit have a different answer if you have this squared x like that. If we have the same denominator, for example, like this, the exceptions, if we want to focus on real numbers, which calculus is based on, most problem is taking on the real numbers. So when that is happened, then this x cannot be 0, cannot be negative, but it can be 0, right? It can be 0. So this probably we have is x greater or equal 0, right? Then that will be the domain if this happens. Or if you want to write in terms of interval, you can write the interval. Just so if you want to write using the closed circle, you can write like having a little bit, having an angle here, okay? And if you write an open circle, you draw a curve, like a curve, a bracket like a curve. And in the line numbers, you can write this and then this, and this is your domain. Okay. Okay, so some problems on domain. What I want to conclude, or summary. Okay, we have at least three set of problems, okay, in domain. The first one is rational. You have a function that is a fraction. You can have 2x over x squared minus 1, or maybe x squared plus 3, like that. Okay. So the important thing for this particular case is you just keep an eye on the denominator. That is the one that you will need to be aware that this one here should not be 0, so that the function will be defined and still in a real number. Okay. And the second is when you have a square root or even root, or square root. So it can be anything inside. It can be a square root of x or any functions there. So if this happens, then this inside here should be greater or equal 0. Okay. And of course, if the problem is mixed, then you need to find the common between. And actually there is another one. If you have any logarithm, okay, if you have a log or ln, it's right log, then this should be positive and should be greater than 0, because logarithmic in a 0, that will be undefined as well. Okay. I think this 3 exception is, I think, the very basic in looking for or set up the domain on a function. Okay, that's the domain. Okay, maybe any questions first? So some of the problem will be, I think, mixed between maybe square root or maybe with the fractions or maybe with the log. Okay, and that's when you choose to be aware of the domain. Okay? Because basically, in calculus, the default domain for every function is they should be in a real numbers. But of course, every function they have a different setup. They have different setup, and sometimes when they maybe like this one, they can have a potential for some numbers to be outside of real numbers. Like this one, it can be 0, but it should not be, because we want it to be in a real number. Right? Okay. Another basic fundamentals is okay. Let me go to next page. Another one is about the even and odd functions. I will go just the basic one. The maybe even is just going to the x squared. Let's say we have the x squared. And the odd one, let's say we have the cubic. Okay, so for even functions, if you look here, if we set up some value, a, and maybe here is minus a, they both will have the same values, right? They both will have the same values. So when we have the FA is the same as F minus A. Okay. So we can write in summary, in conclusions, that even functions, for even function, that is, if we have negative x, it should be equal with x. Okay. So when you want to check, okay, some functions, whether it is even or not, just changing or plug in the negative x. If it is going to be the original function itself, then it is an even function. Okay. Okay, that's the even functions, and the other here is let's say we have also similar condition. In odd functions, however, when you plug in a and negative a, you will get the result that is, oh, not here, it should be on x. It should be similar value but opposite signs, right? So this will be probably FA. This will be probably the negative of F of A. So for odd, well, we have this opposite sign. So whenever you plug in the negative x onto some maybe random function, and you find that it's resulting, it becomes the opposite sign of the original function, then it will be the odd function. This even and odd function seems pretty basic, but actually in determining some higher problem in integrations or maybe in derivatives, sometimes it can be helpful, especially some problem in integral. Okay. Some problem in integral. You can have, well, because it's odd functions, then you can maybe subtract the integral and make it in zero, which probably can be explained. Okay. So basically, even functions checked with a negative x should be back to the original. Odd functions checking, and it's the opposite signs of the original. Okay. I will just go reviewing some basics for today. Okay. Okay. The next is let me write these two equations. This is if okay, and the question is sketch the function. Okay, if you remember, this is we call a piecewise defined function. Piecewise defined. Okay, so piecewise defined functions is a function. If I'm going to ask you, Is this one function or two functions? One or two? One. Yeah, one, right. Okay. One, but it has two equations. So that's piecewise. It's still just a function f, but it has two different equations. So how to sketch is basically we set up which one is our interval, and then we can sketch the graph. Okay. If you're not familiar with how to graph this, you can take slowly first. 1 minus x squared. So you can start with maybe from here. Okay. And you know that the x should be crossing the -1 and 1. That's the root of the equations. And then you have 1 as your maximum point that it can be. Okay. And then you can draw the graph. Maybe draw the graph like the whole graph first. Okay. Maybe it will be like this. And maybe I will draw the other one with some dots. So this will be 1 minus x squared. Okay. And also, another point is if you have x squared like this, like u, then if you have negative part of it, then this should be the opposite sides. Okay? Remember that. We'll have another time to review later. So this will be -1 and 1. I will start slowly, but I'm expecting you to view this part and then become more familiar with it. And if you see any piecewise or any functions, then you can quickly put in image, okay, put in your mind how to visualize the graph. Okay? And then the other one is 2x plus 1. It's just a linear graph. Okay? Just a linear graph. It has a gradient 2. The slope is 2, which means that it's faster 2 points, 2 points, 2 points. Okay? Every 2 points. So every 1 get 2. Every 1 is get 2. Okay? When you move 1, it go up 2. Okay? If you 1, it go up 2. Okay? So if you move 2, it go 4. If you move 3, it go 6. Okay? So it should be maybe around like this. Maybe. Okay. Just okay. As long as your drawing seems proportional, it doesn't need to be exactly the same, but as long as it's proportional, I think that should be okay if you draw the graph. Okay. So this should be 2x plus 1. And this is 0 here. Okay. And this is the fx. And sometimes the graph in piecewise defined function, sometimes maybe it has some discontinuity, and later we can learn about that in limit and continuity. But we call this, if it doesn't have anything in between, then you can say that function is continuously drawn, or the function is continuing. Okay? Okay, so that's the function. So we call this piecewise defined functions. Okay, and let's say we have two functions. Okay, let me just write down first. So today will be a various review on some basics, some fundamentals about functions, domain, piecewise functions, and this one is we have two functions, and if you have this, anyone remember what is this? Okay. So this is called the composite. Okay, the composite function, not composite of the material in material science. It's a different thing. Okay, the composite. Okay, it's a composition. So which means that this is, we can write as f like that. So meaning we have a function inside a function, okay? And we can have many possibilities, and it can have its own like this. It can be also this problem, or we can have also this, and all possible composite function from these two. Okay. So which means that if we have this f of g of x, then the function g will be inside of function x. So you need to put inside this equation to this x. So we take the g as x in our f. Okay. So for example, let me just show you one, and then we can move on. And you can I think you can solve it. Okay. Okay, so we call this composite. Or compositions. Okay, composition. Okay, another basics is about the how to read a graph. The basic one, how to sketch a graph. Okay. Okay, let's make the functions. Let's just take the linear functions. Okay. Maybe that. Let's say this is a random functions, linear functions. And from these functions, we call, probably I will write, this is the transformation of functions. So you can try to sketch the other one. And let me make copy, maybe right here. Okay. So for transformations, this is a reviewing. Hopefully, you still remember. We have a functions here. Actually, it can be any function, but to make it simple and easy to watch, and let me make this is a linear function. Sketch the negative of a function. Remember that we learned a little before about the odd functions, and when it has the negative or opposite. If you remember the how the function property and behavior. If you have this, then the negative will be this, right? Okay. The negative you mirror on x, right? Okay. You mirror on x. So it should be okay. So it's just going down there. Okay. That's the negative f of x. Okay. What's happened if you have the f with negative x? You mirror on this side. Let me put this a little bit outside here. Okay, the second one is having twice of the functions and then minus 1. So at least if you look on the linear one, if you multiply with a constant, at least the gradient should be multiplied. Right? So at least the gradient should be multiplied, and it will be more having higher gradient, right? Higher gradient. So if you ignore this negative one, it should be like this, right? But then you have negative one, so you need to shift going down, right? Okay. So it should be I think yeah, around that. So this will be 2 f of x minus 1. But it will be a little bit different if you are having f and inside 2x, right? It will be a little bit different. The contractions will be different. This is the contraction in a vertical, and if this is 2x, the contraction will be horizontal. Okay? Horizontal. Hopefully, I can give some maybe a little bit homework, but that will be later. Here. Okay, the next one is the third case. At x plus 3 plus 2. I think to make the picture looks good, let me change the question. Okay, let me change the question with minus. Okay. Okay. If not, then it will be messy. Hopefully, good. Okay. So x minus 3 is have minus inside of the functions. If you have x minus, then you need to shift 3 times. Okay. So shift the graph first to the right 3 times, 3 units, and then shift 2 plus 2. So after you shift here, you're going up twice, right? 2 units. So we can so 1, 2, 3, and then 1 and 2, maybe here. Maybe around here, around there. Okay. So this will be x minus 3 plus 2. Okay, I hope this little review can help you remember on some sketching, some transformation of the functions. Okay. 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 Okay, let me just go. Okay. Or maybe any questions first? Any discussion? Okay, let me go to some essential functions for you. Okay, some essential functions. Okay. Essential functions. The first one, as you have learned, is a linear function. This is if it's just a constant. This is a typical linear functions, mx plus b. And then power functions. This is, I think, pretty familiar. It's x squared, x cubed, and so on. I think you also know how to draw and at least how it looks like. And then the root function is like the square root of x and so on. So this will be this is f of x. But remember, in the cubic, it will be considered the negative as well. And the reciprocal function, which is the 1 over x with power of n. This is going to be like this. And this is going to be like this. Okay. This is just 1 over x. If I have 1 over x squared, then it should become all positive y, right? Okay, and then the other one is the exponent and log. Let me put it to the next page. This is just any constant b with power of x, and b is a positive number. Should be 1, this should be 1. This is log when b is less than 1, then it should be here. And of course, the other one is the trigonometric, and I think you are familiar with sine x, cos x, and tangent. Okay, I don't think I need to draw that. Okay, I think last section is the inverse. Okay, basically the inverse means that the inverse is basically you have domain, you have range, right? Basically the inverse, technically, you switch the domain and range. Okay? But to do the inverse, we need to have some requirements of the function itself. Okay? So first is we need to learn on, or we need to know that the function needs to be one-to-one function. Okay. What is one-to-one function indeed? So if we imagine that there are two set of, let's say this is A, this is B, okay, and we put some component inside A and put some component inside B, and then we set up some arrow like this to note that this is actually a function. Okay, so you set up from domain to range. Okay, so we mentioned A is domain, B is range. So each element inside A, they are going to have set element exactly one on each A but each B. Okay, so this is let's say this is 1, 2, 3, 4. This is A, B, C, D. Each of them get their own target. Okay. We call this is one-to-one function. Okay.
Can you give an example?
Okay. Example, I think I will just give you the exception. I think it will be better. Let me just draw the sign x. Okay. It is it's going to have like all the time like that, right? If you imagine it's a sign x. Okay. You always have a maximum of sign is 1 and the minimum is -1, right? At this point here, or maybe I'm writing from here, from the back side also. Okay. Let me just start from 0 here. 0, and then maybe 5 over something 6, maybe 5, maybe you'll have this, right? Up until you have the maximum point, you're still okay, right? Still okay. Let me just make this. It's still okay here. Still okay, still okay. But when you get here, you get somewhere around here, you get the same value, right? The same value as this x, right? So 2x has the same value. It's not one-to-one. Okay? It's not one-to-one. One-to-one is this from 0 here until pi over 2 is still one-to-one. Or maybe from here, it's still one-to-one, right? So let me get you. Okay. So basically, if you take all the x inside, we can say the sign x on that case is not having an inverse. You cannot have an inverse. But we have, right? If we limit the x, we can have inverse. So this is one-to-one. But if you take all, then it's not one-to-one because this 2x here has the same value and it's not one-to-one. So if you have let's say this, and then it's going to have this. Now this is not one-to-one. Okay? Okay. And then how we can set up this is one-to-one or not one-to-one immediately from the graph. We can have, it's called the horizontal line test. Okay, it's called the horizontal line. So this is horizontal line. So horizontal line test is basically a practical way to tell or to determine whether it's having an inverse or not, or it is one-to-one function or not. Okay? So if you have 1 and then 2, then it's not one-to-one. If it's only having 1, then it's one-to-one function. So if we just limit here, just limit at this certain area, the domain of the signs, it's practically 1, 1, 1, 1, 1, 1, right? So we say at that domain, our inverse is one-to-one. Our sign is one-to-one function, and thus it has an inverse. Okay? So this is horizontal line. This is to check whether function has one-to-one. One function is one-to-one function or not. If it is, if the line crossing more than 1, which means it's not one-to-one function. Okay, I think I will stop here until here. Okay, so this is basically a review of some functions, basics, transformations, inverse. Okay, and the next class we will going into the calculus. Okay, the calculus part. Okay, so this is about the function. Okay, before we set up our calculus in limit. Okay, I think we'll stop until here.